Good morning. I'm Venkatesh. I'm from EC department. I'm going to give an introduction for a VLSI design. So here we are going to discuss the fundamental concept of P-type material and N-type material, and how the PN junction diode forms, and how NPN and PNPN transistor works. And based on that concept, we are going to have the constructions of NPN and PNPN transistors. Silicon in room temperature, it behaves a poor conductor, so we are going to add a few impurities in order to improve the electrical property of silicon. So silicon is a group 4 element which is combined with group 5 element, or it can be combined with group 3 element to form P-type and N-type materials. If we want to form P-type material, we need to add the silicon with group 3 element such as boron or aluminum. If you want to form N-type material, we need to combine the silicon with group 5 element, which is extra electron. The materials like arsenic and phosphorus are used to form N-type materials. When we combine P-type and N-type material, which forms PN junction diode. PN junction diode is first semiconductor device which can be used as a switch. Now there are two types of transistors we are going to see. One is PMOS transistor, other one is NMOS transistor. PMOS transistor, the majority carriers are holes. NMOS transistor, majority carriers are electrons. So let us take NMOS transistor, how it is being constructed. In order to construct NMOS transistor, we need to take a P-type substrate. From P-type substrate, we are going to derive a fourth terminal called bulk or substrate, and in P-type substrate we are going to diffuse two N layers, and which forms source and drain of NMOS transistor. And over this P-type substrate we are going to put SiO2 insulator and polysilicon, which is a semiconductor material, which is a metal. These three stacks are combined together called MOS stack. Metal, oxide is an insulator, semiconductor. And based on this we construct an NMOS transistor. Normally in NMOS transistor we will not have any current conduction when the channel is not formed. In order to form channel, we need to apply gate voltage. If gate voltage is greater than threshold voltage, channel will be formed. Forming a channel will not lead to current conduction, so we need to make a potential difference between source and drain region. If we make potential difference between drain to source region, there will be flow of carrier from source to drain. If carrier start moving from source to drain, there will be current flow between drain to source. That current is called as IDS. There are three regions of operation we can have for NMOS transistor. One is cutoff. During cutoff, VGS is less than VT. That means the voltage which we are applying at gate region is less than threshold voltage. If you apply less than threshold voltage, the NMOS transistor is said to be off. There is no IDS. If we apply gate voltage greater than or equal to VT, that means the threshold voltage, there will be a formation of channel. And if formation of channel is there, that will not form current conduction. So we must make potential difference between drain and source. If we make potential difference, there will be current flow. That current flow is IDS. and this particular region is called as linear region. And there is one more region called saturation region. In order to form saturation region, same condition we must do as like a linear region. We are going to make VGS greater than VT, and as far as saturation region is concerned, the channel is not going to be narrow, instead it will be a tilted channel. That means the active portion of the channel will be much concentrated on source region instead of drain region. Drain region is in sort of channel, and due to that saturation region comes, and this particular region is called as pinch off region. And this NMOS transistor goes to pinch off region, and we cannot bring back this to active region or cut off region.